This Week in Virology, the podcast about viruses, the kind that make you sick. From ESCV 2023, this is TWiV, This Week in Virology, a special episode recorded on August 31st, 2023. I'm Vincent Racaniello, and you're listening to the podcast all about viruses. This is part 2 of ESCV coverage. ESCV is the European Society for Clinical Virology. We're having a meeting of the society in Milan, Italy, Milano, Italy, and I've collected some of the participants at this meeting to have a chat about their work. And today my co-host is from the NHS Blood and Transplant in the UK, Heli Harvala. Hello, Heli.
Good morning.
Good morning.
Nice to be here.
It's very early, right? It's 8 a.m. here.
It's early, but it's lovely.
But thank you for joining me. You were on the TWiV in Copenhagen.
That's right. Yeah, a
at the
few years ago.
ESCV, using
Yeah.
big data to do public health analysis, right?
That's
Remember
correct. Yeah.
So Ellie's going to help me speak with our guest today, who is from the European CDC in Stockholm, Eeva Broberg. Welcome to TWiV.
Thank you so much.
Good morning.
Good morning. Thank you for having me.
Sure, my pleasure. Eva, right? Eva is the way to say it.
Yes, Eva. Yeah.
So I'd like to talk about your work at the ECDC, but first, I always like to hear about the history of scientists. So you're from Finland originally, correct?
I am from Finland, Turku.
Turku?
Turku, yes. That's my hometown.
Is this where you're from as well, Hallie?
No, I come from northern Finland, but I studied in Turku, and we actually did the PhDs at the same time with Eeva in Turku.
Oh, so you know each other a long time.
So that's true. Since
Okay.
early 2000s.
Okay. What's the name of the university?
University of Turku.
Oh, okay. So you went to University of Turku for your PhD.
I did, yes.
What before that, where did you go to university?
Yeah, actually I started my master's in biochemistry at the Swedish-speaking university, which is called Åbo Academy. And there I did my undergraduate levels. I actually started also already on my master's work in the lab of the professor there, doing some nerve calcium channel studies. Was very interesting. But then suddenly the professor left the university to go to Sweden, and he took all of his equipment with him. So I was left alone a bit in the lab without any equipment, and so I then transferred to University of Turku for my master's.
So were you always interested in science in school, or did that come later?
My interest for science started actually when I was doing an exchange year in Germany in the high school years. And there the biology teacher was very knowledgeable and was giving us much deeper level of science lectures than what I was used to from my studies in Finland. And there I actually then decided that yes, biochemistry will be my subject, and wanted to do a PhD. So I decided it already without knowing where I will be ending up with my master's.
So then you stayed on at Turku to do a PhD, or you returned to Turku?
Yes, I returned from Germany to Turku. I did my high school to the end there, and then I started my biochemistry studies at the Åbo Academy. And then when transferring to University of Turku, I was looking for a new master's lab, a place for my master's studies there, or my master's thesis. And at that time, we had an opportunity to go to the medical school for molecular virology lecture. And there was a teacher or a lecturer, Veijo Hukkanen, who after the lecture said that he would have a master's thesis opportunity in his lab. And so I got very interested because it was fascinating. I never had studied virology, and so it was very interesting and topic. I wrote him a letter at that time. We didn't have yet emails, and it's quite interesting how the world has developed after that. Yeah. So, and I found his mail box at the university and left the letter there, and then I heard nothing for many weeks, and I got worried that he might not be interested in me, and so I went again and insisted a little bit. And finally I got to the Department of Virology to do my master's thesis there. And that was then the start of my PhD studies actually as well. So I finished my master's there and then continued with my PhD.
Who did you do your PhD with?
Veijo Hukkanen, he was there as a lecturer, a clinical lecturer at the university, at the medical school, at the Department of Virology.
And what virus did you work on?
I worked actually on herpes simplex virus. Yeah, so a completely different topic that I'm working now on. But I got into a project where they were doing a lot of in vivo work on an animal model of MS disease. So, and then developing actually gene therapy vectors based on herpes simplex virus, then to test on those mice if we could find a way to stop the demyelinization or to cure it, and so that was my PhD work, and also I was studying immunology of HSV infection and such.
It's interesting you say MS because now there's a good connection between MS and EBV infection. You may have seen some of the recent papers, and I was just in Vermont last week, and my guest was working on that and trying to make a mouse model of EBV. The problem with the herpes virus is they're very host specific.
Yes.
So
yes.
not easy to make animal models.
No, absolutely true, yeah.
So after your PhD, where did you go next?
So I stayed quite a while at the department. I was throughout my PhD work. I was also involved in the diagnostic service there. So at that time, there was a large diagnostic service for serving actually the whole country. So we got specimens from Lapland to the very south and to the east of Finland. So hospitals who had contract with our laboratory, they were sending specimens to us, and so I was involved in that diagnostic work from early on as kind of a side job of my PhD work, and it was a great opportunity to get to know the basic virology techniques, virus isolation, for example, and the traditional virology diagnostics. There was a lot of development at that time on quantitative PCR. I got an opportunity also to develop some new assays for our laboratory on human herpes virus 6 and 7, for example, and such. So I stayed at the department and was also teaching there, and but however, then at some point I was thinking that I want to maybe do a postdoc, so I was also at the US CDC for some interviews, but at that time they said that they didn't have really good funding, as the funding was really reduced due to the government in US at that point, and but got an opportunity in Athens in and
Athens, Greece.
no,
Georgia.
no, Georgia.
Wow.
Yes.
I was just there a few weeks ago.
Yeah, really.
Yeah, for ASV, American Society
Yeah.
for Virology.
Yeah, so it's interesting. But then what happened was that I actually got another offer from a company in Turku. It's called Orion Pharma, a pharmaceutical company that was developing central nervous system drugs for Parkinson's, Alzheimer, depression, and such. And based on my work on MS, I then started there and was doing also animal work there and testing drugs and such. So that was kind of a sidetrack, but an interesting one. But my longing was really to go back to virology, and that's when I then applied to David Knipe's lab at the Harvard Medical School, back to herpes viruses and back to herpes-based vectors also. So so that was my path then to do a postdoc in the US.
And after that, you came back to Europe, is that right?
Yes. So after that, I then returned to Turku. I did a second postdoc back at my old department in Timo Hypiä's laboratory on rhinoviruses, and that was the start actually for me to go to respiratory viruses. Apart from my diagnostic work, where of course the respiratory viruses were already included.
And then after that, you went to the CDC in Stockholm, is that right?
Yes, but before that, actually, there was a global event. So the 2009-10 influenza pandemic started, and there we had busy times in the diagnostic laboratory. We were developing a lot of new assays, and robotics and all of that was quite new to implement very quickly, to change the shifts from one shift to 3 shifts in the day for the technicians, and all of that work I was involved in. And during that work, I then was looking into information on the pandemic and found European CDC's pages, and I had not even known of, to my ignorance, must say, it's a bit, did not even know of European CDC existence at that time. It was a very new institute, and they were advertising for a virologist, and that doesn't happen so often that you see a post named for a virologist, and so I decided to apply, and since then, January 2010, I'm then at European CDC.
So you were in Timo's lab at the same time as Eeva?
No, I was in Timo's lab when Eeva was doing a PhD with Veijo, so before that. And I left Finland in 2003, day after my PhD viva, to go to do a postdoc in Scotland, in Glasgow, with David Evans in polioviruses, and then went back to clinical medicine. So so Eeva left a little bit me and then returned, so I was already in UK at that time, but still in touch with Timo.
I find it interesting how, so in Europe, you move from country to country very easily, and so you're working in Sweden, and you're from Finland, but that seems to be okay. In the U.S., we don't have these country-to-country opportunities, but we do have state-to-state movements, which I suppose it's not the same, because different countries in Europe are very different, whereas the states in the U.S. are similar.
Yeah, so it is very different, because the countries are still countries of their own.
Yes.
So they have their own administrative systems, how you register to all of the services. Most of the countries have their own language.
Of course.
So that's already a big hurdle when you move from one country to another. And school systems are quite different. But with EU, so the European Union, many of the university grading systems, for example, have been standardized. And there is a great program called Erasmus in Europe to enhance the mobility of students to go to different countries for a term.
Yeah.
But this is quite new, so it didn't exist yet during our study time with Heli. But now many university students go abroad in Europe for one term for exchange.
It's very easy to move around the U.S. People think nothing of going from New York to California, but I think culturally it's harder in Europe. So you're both from Finland. You're in Sweden. You're in the UK, right? So you don't even think of this as a problem, right?
No, I think things from the UK perspective have slightly changed with the Brexit. So now it would be much harder, even having a visiting students, you need to do a lot more paperwork. So it has unfortunately changed for worse, but otherwise, those countries which are part of the EU, traveling is easy.
So would you rather work in Finland in the end, do you think, or have you been happy to be in the UK?
UK is amazing for virology. I think I'm still absolutely amazed about the amount of infections, also involved with diagnostic with Eeva in the early days, and when I went back to Scotland we had cases of measles, mumps, but I thought that they had been eliminated, and number of hepatitis and HIV, it's just a different world. But so from that point, really amazing to work there, but no, I do miss Finland and the nature and the emptiness of it.
So let's talk a little bit about ECDC.
Sure.
So how old is it as an institution?
So ECDC was established only in 2005. Yeah, so it's still rather new, now more established than when I joined, but so I joined in 2010 when it's only was 5 years old.
So the headquarters are in Stockholm? Is that
Yes.
correct? Are there remote labs in other countries, or is that the only one?
So that's the only place of the institute. But actually, now that you mentioned labs, we don't have labs. So that's maybe interesting for the virology audience here. So European CDC does not have any laboratories of its own.
And so it's called European. So does it really deal with all of Europe, and is that a challenge to get all these diverse countries to listen? In the U.S., the CDC has no power to dictate. They can only suggest. So what does the European CDC do?
So we do work with all of the European Union and European Economic Area countries. So Norway, Iceland, Liechtenstein also included. And then for some of the diseases that we deal with, and just to note here also that our institute is focused only on infectious diseases so far, so we don't have the non-communicable diseases side
like CDC,
yet.
Okay.
So we focus only on infectious diseases. But so for certain diseases like influenza, RSV, COVID, HIV, TB, we work very closely with WHO European region, the office of WHO in Copenhagen, and they span with 53 countries, the whole WHO European region. So we collect also data from those countries to ECDC then.
So you're collecting data to observe infectious disease trends. You're not issuing policies like this. The American CDC issues vaccination policies. You don't do the same thing, right?
So you mentioned that the CDC cannot dictate what the states do. So we work in a similar way with the European Union and EEA countries. So we can issue certain recommendations. We give suggestions, but we also cannot dictate to the member states what they then do. And so we work very closely with the countries, and we work through networks. So networks of public health institutes and we both on the laboratory side, but also on the epidemiology side. So we foster collaboration through these networks. We host a lot of expert meetings on a regular basis within our networks, and with that have a dialogue with the countries, because they are all different and they have different surveillance systems also. So we need to listen very carefully what type of systems they have, and where there are then opportunities to harmonize or standardize systems, we try to do that, and also possibly to support the countries as much as possible with the funds we have available through capacity building. So that's how we mostly work.
So you mentioned funds. So who pays for the European CDC? Does everyone chip in?
So the funding comes directly from Commission, from European Commission. So it's centrally funded directly from the EU funds, which of course in the end come from the member states.
So Heli, I suspect that blood and transplant interacts with ECDC to some extent, right?
Yes, so they have a part of it's kind of oversees the substances of human origins. And that's where it used to interact before Brexit.
Before Brexit, yeah. Okay.
Yeah.
So, Eeva, what do you do at the ECDC? Tell us about your work.
Yes, so at the moment I work in a group which is called Respiratory Viruses and Legionella. And as the name tells, we focus on respiratory viruses, and there are also experts in our group who focus on Legionella disease. And my focus is as a virologist on the laboratory side of work, and I focus very much on seasonal influenza, RSV, so the respiratory syncytial virus, and SARS-CoV-2.
So if you don't have labs, where do you get your data from?
Yes, that's an important question. So as I mentioned, these networks of experts and networks of public health institutes in EU. So we work, we host those networks, and they are our partners. So the country laboratories, the public health institutes have mostly those laboratories that we work with, and they collect the specimens, they analyze them, and they submit then the detection data to us. And also in terms of standardizing techniques, quality assessment and such, we work with these laboratories. But as we don't have laboratories of our own, we also establish contracts with certain specialized laboratories where we need work to support the other member states who might not have the same level of capacity. So we contract these specialized laboratories to provide training, laboratory wet lab training, and also bioinformatics training and such for the member state laboratories experts who need that. We also conduct external quality assessment rounds. So for all of our surveillance data where there is laboratory data involved, we have external quality assessment, and those we also conduct through contracts. And then there are certain other activities that we contract, and so we pay for the activities as we don't have our own labs.
Got it. So last night you mentioned that you have two kinds of surveillance, right? You have just screening, and then when there are infections in people, you get that information as well. Can you tell us about that?
Yeah, so...
you had a name for them too, I don't remember.
Yeah, so we have kind of two types of surveillance. So something that is called event-based surveillance. So we do a lot of threat detection at ECDC. So there are specialized response and threat detection groups at ECDC who focus on daily looking into any global threats through media, through any signals that are available through certain outlets, and those are then discussed in a daily so-called roundtable meeting that we host. And then there are decisions made if, for example, a risk assessment should be taken forward. So we work a lot through these risk assessments at the ECDC to assess the risk for the European Union member states from infectious diseases. So that's one way of conducting surveillance. And then we have indicator-based surveillance. And there we have agreed indicators, mostly case definitions for the diseases that we discuss with the expert networks and agree on. And then there is a list of these case definitions and diseases that we focus on. And the member states are obliged to report those diseases to us. So those are the notifiable diseases within EU then. And for those we receive, for example, for seasonal influenza, weekly data then from all of the member states.
So what is the goal of the surveillance? Whether it's a case by case or an overall, what do you do if you see an uptick in influenza, for example? What would the agency do?
So if we now take, for example, the example of why not seasonal influenza? So there, the major surveillance goal is to define the vaccine strains. Okay. So from the virology perspective, so we collect data on the circulating influenza strains in Europe. We collect those data twice a year. We look at those on a weekly basis, and we publish a bulletin also on that, so we follow it throughout the year. But there are specific moments in the year when we collect the information for WHO and for the vaccine composition meetings. And there we take a deeper look into the virus strains, and we submit all of those data then to WHO, and there, of course, the WHO collaborating centers with their own data, also in-depth data on the vaccine or the virus strains. All of this is discussed, and then there is a recommendation made for the vaccine composition. And this is done for the Northern Hemisphere and then for the Southern Hemisphere separately. And but a lot of our data collections aim for knowing what is going on in the member states. So what is the level of infectious diseases? Are there any unknowns in the surveillance data? What public measures should be taken? So then we issue, of course, these recommendations. For example, there can be recommendations how the COVID vaccines, or discussions with the member states, how should the COVID vaccine schedule now look like, and such. So a lot is about the public health measures then, based on the surveillance data.
So I'm curious, do you do year-round influenza surveillance?
Yes.
Not just when people are sick in the winter, right? You do year-round. And you see virus all year round?
Yes. So we collect seasonal influenza data on a weekly basis.
Right.
And we we issue a weekly bulletin where we publish all of those data. So the member states have different types of surveillance systems also for influenza. So some are basing it on acute respiratory infection case definition. Some use the more specific influenza-like illness case definition. And then based on those case definitions, they perform testing. And not all of the cases get tested, but a subset is tested. And those data are then submitted to us on a weekly basis. And we do this year-round, so countries can submit data all weeks. Of course, some member states have chosen not to perform surveillance year-round, so it's a country decision if they do this. But most or all of the member states have surveillance in place from week 40 to week 20, and then I would say most of the countries also perform some kind of a surveillance during the summer.
So what would you say is the level of influenza virus circulation in the summer compared to the winter? What percent of
It's very low, but there are detections throughout the summer also. So sporadic detections of all of the viruses, but mostly maybe H1 and H3.
Okay.
Yeah.
So now the reason I'm asking is we're trying to establish the seasonality of SARS-CoV-2, right? You're seeing it in the summer still, right?
Yeah, so there is no seasonality yet for SARS-CoV-2. So I think most of us who work with seasonal viruses are expecting that somehow that SARS-CoV-2 would also kind of go to the seasonal rhythm of also seasonal coronaviruses, but that has not happened yet. So it's an interesting phenomenon that SARS-CoV-2 is circulating throughout the year, and also still causing some peaks also during the spring and summer times.
Yeah.
So and we are also now seeing an uptick in the EU.
Mm-hmm. Do you track the seasonal coronaviruses at all?
No, not actually not. So we know that many of the member states are detecting those and doing diagnostics on those viruses, but we don't collect systematically those data.
I wonder if when a virus first causes a pandemic, that seasonality is not happening, because 2009 was. Influenza was also at a weird time of year.
Yes, it was.
So maybe it takes some cycles to establish. So maybe seasonality, we don't understand it, but maybe it's a combination of environmental and immunological factors.
Absolutely, yes, sure.
So let's talk a little bit about the onset of COVID. How did ECDC respond, and when did it start? Because you were involved, obviously. Tell us what happened there.
So it was very late in December 2019 when we got the first signal from China, and that was through our event-based surveillance activities, so through the threat detection activities, and so we heard of this unknown origin pneumonia, and we're not quite sure what's going on there, but started following it very, very tightly. And very quickly then in January, it became clear that it's more serious than what it was maybe first thought of. And so very quickly then we established a group of laboratories, a network of laboratories to work with, because we could not assume directly that those would be our regular influenza laboratory network. But we had to establish a new COVID surveillance network and laboratory expert network. And we started looking into capacities in the member states to detect the virus. So already in I think it was 10th of January or something when the first sequence was published, wasn't it? And then maybe in 10 days from that, a group from Christian Drosten's group in Charité in Germany published already their first diagnostic assay, and so it was very quick information exchange also between the member states and the public health laboratories there, and the laboratories had to, of course, very quickly then start applying new PCR systems or set up new detection systems for this new virus. And so we started looking into those capacities already in end of January 2020, how many laboratories in EU could detect this new virus, because of course there was a lot of travel, global travel from China and to Europe. And it didn't take long when the first detections were then reported from
So roughly
from Europe.
When do you think laboratory diagnostic tests were established and efficiently running? When would that be in 2020?
End of January, I would say already.
Yeah,
so
much earlier than the U.S., unfortunately.
Yeah, so it went very quickly, but of course we were a little bit naive in that sense that we thought that I thought also that we would have very good capacities in the member states, and that we would be well prepared for a respiratory virus like this coming our way. So at that time there was no mention of human-to-human transmission even yet. So
not that we knew of, but it was happening, yeah, obviously, right?
Yeah, so when we did our first capacity mapping, we had I remember numbers like 8,000 tests per week could be performed, and we thought that, wow, this is a good number. Yes, of course we can detect these waves easily with the capacity that we have in the EU, and the laboratories are well prepared. And no, so then of course what happened was suddenly that there were no plasticware. So how could that happen? I remember it was maybe March, April or something, and I started getting signals from the laboratories from the member states that they don't have enough pipette tips, or they don't have enough tubes to Eppendorf tubes and such. And where were those materials coming from? Mostly from China, which were closing the export and also the productions. And so who could have thought of this situation?
Yeah.
Other equipment and laboratory materials, the PPEs for the hospitals. Like there was such a demand of just gloves.
Even non-COVID work, right? Same thing with your place?
Yeah, and we were also involved with COVID. We were collecting convalescent plasma and actually joined a couple of meetings with ECDC with what we were doing in terms of antibody testing and getting that up and running very quickly.
Did you use any wastewater surveillance at all?
Not in the beginning, but now it has grown actually quite big. So I don't remember now exactly when it first started. There were, of course, member states who had been doing wastewater surveillance for other purposes, mainly for polio and enterovirus surveillance. But then at some point of the pandemic, when the testing was not anymore so comprehensive. So of course, when people didn't feel that they need to go for testing anymore, and they had received their vaccinations, and they were not so concerned of COVID. And also the self-testing became quite available, the home tests and such. So all of us know that we also take the home test quite easily, and not to go to any GP clinic for testing. And so the surveillance data were suddenly not available anymore. So when the testing is not there, it also dramatically affects then the data that we receive and how we can rely on the data. So we need to think now completely new that, okay, how could wastewater surveillance, for example, contribute to the overall information of which viruses are circulating, which variants of COVID or SARS-CoV-2 are circulating, and how the methods will develop to detect also new variants, because it's been mainly now focusing on known variants.
So currently you do use those data from wastewater?
So there is another commission services called Joint Research Center, and they have established another network who work on the wastewater surveillance, and they have also ways of collecting those data. But I would say that it's still quite unstandardized, so it's not that easy to compare data from country to country. The collection methods and the detection methods are somewhat different, but it's coming closer, and we find those data also very useful.
So you mentioned RSV, respiratory syncytial virus. It's one of the viruses you track. So what's going on now with that? Because there have been outbreaks in other countries.
Yeah, so there we have a lot of work ongoing, and so RSV has or is not yet a notifiable disease in the EU, and it has been detected and also the data submitted to us based on the influenza surveillance. So many countries have been doing RSV surveillance as part of their influenza surveillance work, using the same case definition, influenza-like illness or the acute respiratory infection, ARI, case definition. And so we have knowledge of RSV seasonality since many years, more than a decade, and we have seen that there is a very regular seasonality of RSV in Europe, but there hasn't been any vaccine, and there hasn't been the same need for the surveillance data as there is for influenza, and also the RSV disease burden has not been so established in Europe. It has not been recognized as such a severe disease as it is in Europe as influenza has been. And now, since a couple of years, there has been a lot of work focusing on this through certain EU-funded projects. The first one was called RescEU, and then there is a follow-up project called PROMISE at the moment running, and looking into the burden of disease of RSV in Europe, and there is a substantial burden, especially in the very small babies, in the below 6 month and below 3 month olds, and so we are moving toward establishing RSV as a notifiable disease, and we have submitted now just last year a proposal for an expert committee to take RSV on board as a notifiable disease, that step was passed, and now the proposal is with the European Commission for a decision. We hope to receive this decision still this year. And so it's an exciting time for RSV in Europe. And of course, at the same time, there are other important developments on the monoclonal antibody treatment side. So last year there was, so there has been one prophylactic drug for RSV for many years, palivizumab, which is a very expensive drug and has been only used for the most at-risk babies. Now there is a new drug approved by the European Medical Agency from last year, nirsevimab, and that is a very new development. And so we still need to see which countries start to use that new drug. And also, there are now 2 vaccines that are close to the step of being approved. So there is already an approval of EMA for those 2 vaccines, and we are still waiting for the final marketing authorization for those. So it's very exciting times and interesting to see then how these vaccines will be implemented in the member states and how the use of those vaccines and drugs will affect the circulation of RSV and the disease burden.
You mentioned very young babies, but it's also a problem in elderly, right?
Sure, yes.
And you see that in the European countries as well?
Yes.
Okay.
So that's very known, and these first vaccines are actually one of those is focusing on the elderly, and one is for both babies and the elderly.
So we have just 10 minutes left. I don't want to hold people from the next session, but let's talk a little bit about enteroviruses. Do you do any surveillance of respiratory enteroviruses? Because you're a respiratory virus person, right? I guess you would be limited to those.
Yes, so the signals on enterovirus detections or severe infections of enteroviruses have come to us at the CDC through the event-based surveillance mainly. So in 2014, there was a big outbreak of enterovirus D68 in the US and Canada, and there were severe cases with acute flaccid myelitis, so AFM cases with paralysis similar to polio, and that was of course quite a frightening situation for many of the families that were affected, and so we started looking at this also in Europe then a bit more closely. And we, at that time, we established a connection with ESCV, actually, the Society of Clinical Virology, and there was a working group established, and so through that work, we did a study and noticed that the same virus, very similar also genetically as the one circulating in the North America at that time, was also circulating in Europe, and it was widespread. However, we didn't see that many of those severe cases. So it was interesting that in the US there were a lot of these AFM cases, and but we didn't see quite the level of severity of the infections in Europe, and I don't know the why this was so different in the population. What's behind it? The immunity must have been somehow different, and that was the start of a series of work actually. Where we have then been looking at different outbreaks of severe infections with different enteroviruses. So the enterovirus D68 situation was in 2014, and then in in 2016, there was an A71 outbreak first in Spain, but also in other countries then where there were severe neurological outcomes of A71 enterovirus. And then again, in 2 years from that, 2018, there was an echo virus 30, I need to think, because now we are looking at 11, so not to mix up. Echovirus 30 outbreak with very severe meningoencephalitis, meningitis cases. So we've tended to see every 2 years these outbreaks, and then came COVID, which disrupted, of course, the circulation. But now again, we we have an outbreak or maybe not an outbreak, but some detections of severe echovirus 11 cases, and we are looking into that now. So
this kind of periodicity always suggests immunity changes, right?
Yes. So I think it's very complex. Why this periodicity is there for enteroviruses? It must be a combination of how the immunity wanes, maybe. Then a new population, of course, of newborns and small children who are naive to these viruses, and then the antigenic or the different serotypes circulating. So the antigenic changes in the viruses. There are a lot of recombination events with enteroviruses always. So new strains evolving.
Right. So when do you get enough genomic data from these surveillances to see if there are recombinants?
Yes. So as said, we don't collect enterovirus data at the CDC yet through our regular surveillance activities. So these have been kind of specific projects, and there is a network called NPEN, whom we've been then closely collaborating with to study these situations of outbreaks or upticks of severe cases, and looking also into the virus evolution there through genetics.
So, for example, in the outbreaks of Entero 30 or 11, are they all the same virus or similar, or are there distinct isolates from different cases? Do we know?
So usually they are not. So if we compare two cases, so they are not exactly the same as the virus evolution is so quick, but they form certain clades or clusters in that sense that they are similar genetically. But then within these serotypes, there are of course certain genetic types then, and those can be detected globally also.
Okay. So NPEN is the European Non-Polio Enterovirus Network, which when we met in Copenhagen, it had just been started. So give us an update. What's going on with that?
Yeah, thank you. So NPEN, we established that around 7 years ago. And it has been getting bigger and more interest. So basically, our aim is to try to understand the burden of enterovirus infections better. And what we recognize from the early on, that there's quite a lot of data collated at hospital level and also country level, which wasn't systematically pulled together. So we are trying to get that data together with the more defined hospital data as well, and really aiming to get the burden. At the moment, we have members from over 20 European countries and over 70 different hospitals, including most of the public health institutions as well. And it's really active network. We have done work looking at D68 last year. Kim Pensop has been leading that work with Mackie Simoens. and analyzing the sequences, a lot of whole genome data, so understanding the genomics better as well. And I think these studies are also prompting more countries and more hospitals to look for it. So there's still a lot of underlooking for these diseases. Similarly, some work with parvovirus 3, we have pulled data together from over 20 European countries and have better understanding which countries or hospitals are looking or not looking for these infections, which are also affecting really young babies, and it also causes encephalitis. So yeah, so a lot of ongoing work, new studies starting just now with ECHO 11, which we are very glad to be collaborating with ECDC and trying to collate really case-based clinical data on those severely affected young babies. And again, I don't think a lot necessarily has changed with these viruses. These viruses have been going on for years, but they are just completely underreported, and it's really good to see that we are paying attention for the children who are dying with these infections. And I guess if we look data from one hospital or one country, the numbers might be small, but when we start pulling data together from many different countries and hospitals, we are starting to see really where the impact is.
So are these publicly available data?
Yes, obviously data will come publicly available, and we will share it in real time when needed, and very open for any collaborations, and actually have done some work with the American colleagues and AFM network as well. So.
Right, and you can look for the you have a website where you could access the data, is that correct?
Yeah, and directly contacting us might be easier at the moment.
Okay, great. All right, that's our ESCV special episode number 2. The website for TWiV is microbe.tv/TWiV. If you have any questions about this or any other topic, it's TWiV@microbe.tv. And Microbe TV is a science network of, like the NPEN network, it's a science network of educational programs, and we exist by your donations. So if you'd like to help us, you can go to microbe.tv/contribute. My guest today from the European CDC, Eeva Broberg. Thank you so much for explaining all that to us.
Thank you.
We could go on for a lot longer, I suspect. Yeah, but,
absolutely.
But that's good. And my co-host from Blood and Transplant, Heli Harvala. Thank you so much.
Thank you, Vincent. Thank you, Eeva.
I'm Vincent Racaniello. You can find me at microbe.tv. I'd like to thank ESCV 2023 for having TWiV, and you, Heli, for help organizing all of this. You always do that. Thank you very much.
Thanks for coming. It's a pleasure to have you here.
I want to thank the American Society for Virology and the American Society for Microbiology for their support of TWiV, Ronald Jenkins for the music, and Jolene for the timestamps. You've been listening to This Week in Virology. Thanks for joining us. We'll be back next week. Another TWiV is viral.